Assalamualaikum and a very good day. So now we are in week 12, which is still under chapter 4 matrices. But we'll go now the most important part in these matrices that also will cover in your final exam, which is system of linear equation. We go first to the introduction to the system of linear equation, and then you will learn how to solve this system using inverse matrix, and then the last one you will learn how to solve this system using Cramer's rule. So for this week, for this week 12 part 1 video, we will start here by introduction of the system of linear equation and how to solve this system of linear equation using inverse matrix. We go first to the introduction. We need to know what actually is a system. A system is referred to a group or entity object, real or abstract, which comprise a whole with each and every component element interacting. Means that here, the group here, each element in this group will interacting or related to another one. Example of the system are solar system, blood system, and computer system, and also there are many systems in this world. For this picture, I show you one of the example of the system, which is solar system. You can see here it is a group of entity, which is planet, and also in this solar system, every planet here interacting or related to one another. But in mathematics, all the system in this world can be transformed into linear equation, which is in general it is in the form of a11x1, a12x2 plus up to a1n xn, which is equal to some value of b1, and then you can have here a21x1 plus a22x2 plus a2n equal to b2 up to here you have m dimension or m numbers of equation. Means that here we have am1x1 plus am2x2 plus dot 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 plus up to amnxn equal to bm. But when we have such of this linear equation, it is quite hard for us to solve this equation. In this equation, the unknown here, okay, the unknown is given by x. So all x here need to be solved. Means that when you know x, you maybe know some value or some entity in the system. So how to solve this x? We need to transform into matrix. That's why you learn in this chapter about matrix. When we transform in this form of matrix, we have here a matrix in terms of ax equal to b. But what actually is A, X, and B? In this case, A is referred to the coefficient of all X. Here, I can write this A as A11, A12, A1n up to AMN. Means that all the coefficient of X here we transform into matrix form, which is this matrix form is multiplied by our unknown of x1, x2, xn, which is here you can see this coefficient multiplied by each x here. So same when we transform into this matrix form, we have here a vector x, where this A matrix is multiplied by this vector x, and it will be equal to some value of B vector, which is here we have B1, B2, Bm, which is in this equation it is all this B. So we will have here a system of Ax equal to B. The purpose of this chapter is want to solve this x. So what actually are the values of this unknown x? How to solve this x? We start first by solving the system using inverse matrix. This inverse matrix is only applicable for square matrix, which is in square matrix, if you still remember our introduction part, it is a matrix with m equal to n. That is the dimension of the matrix, or number of row equal to number of column. And in this case, the determinant of the matrix cannot be equal to 0, because when it is equal to 0, we are unable to solve the system because it is undefined. So how can we get the formula to solve a system using inverse matrix? We start first, we have previously a system of AX equal to B. So we multiply both by A inverse. We'll have here A inverse A X equal to A inverse B. In this case, A inverse A, it is identity matrix. So we can write I X equal to A inverse B. Any identity matrix multiplied by any vectors of matrix, you will get back this vector. So we'll get back this answer, which is X will be equal to A inverse B. In this case, we know that when we learn about linear system or matrices, our aim is to solve this X. So now our X becomes subject, means that we can solve this one by using inverse matrix where the unknown X equal to A inverse B. So we have to compute first our A inverse and then multiply with B vector. That's why we got here, this one is our formula how we can solve X using inverse matrix. Then we go to this example 1. We want to solve the system of 2x minus 5y equal to 15 equal to 3x plus y equal to 31. What we need to do first, we need to transform this matrix in terms of ax equal to b. In this case, when we transform, we have here 2, negative 5, 3, 1, which is time our unknown x and y equal to 15, 31. If we refer back to the introduction, this one is our A, coefficient of all x and y, and this is unknown x, and this one is vector B. The purpose of this question, when the question asks you to solve the system, means that you need to find what are the value of this unknown. How to solve this by using the method that we have learned so far. So we can use inverse method, which is we know that our inverse method, we have a formula of x equal to A inverse B. The first step, you need to find first, okay, find A inverse. Because we need this A inverse, we can multiply with B that we already have in the question, then we can get our x value. So to find the inverse of this matrix, you need to refer back the previous lecture, which is for 2 by 2, A inverse equal to 1 over AD minus BC times D A negative B negative C. So in this case, we have here, this one is our A, negative 5 is B, 3 is C, and 1 is D. When we want to get this inverse, it is 1 over A times D, which is 2 times 1, minus negative 5 times 3, which is multiplied by the matrix. B is 1, A is 2, negative B, so negative 5 means that here is 5, negative C, so here is negative 3. When we solve this one, we'll get the answer 1 over 17 times 1, 5, negative 3, 2, which is given here by this solution. And then how we can solve this one? we need to apply our previous formula, which is x equal to A inverse B. A inverse B here, our A inverse we already get from here. So we have 1 over 17, 1, 5, negative 3, 2 times B. What is B? B you can get from your question, which is given by 15 and 31. When we multiply this, we'll got here, when I multiply this part, I got 1 over 17 times this matrix times this vector. You have to refer back in the introduction slide. So in this case, it is 1 times 15 plus 5 times 31, and then the second row, negative 3 times 15 plus 2 times 31. When we solve this one, we'll got the answer equal to 10 and 1, which is our x equal to 10 and our y equal to 1. This is the final solution for this question. And this is how we can solve a matrix 2 by 2 by using inverse method.